Thursday VPE. Today we have something very exciting, and this technology has blown my own mind with combining both heat and power to a indoor comfort. So we're going to learn more about this. Please feel free to ask questions. There's two ways for us to ask questions. One is for brave souls to raise their hand. On the bottom of your bar, you'll see a little hand raise it, and I'll unmute you so you can verbally ask it. If not, if you're a little bashful, no worries. There's a Q&A section down right there where you click and you can easily type. I'll be monitoring it. If it's a burning question, just type burning question and what you wish, and I will interrupt Joe. And now you got to help me with your name. I've been repeating it. It's Gokul. So both these gentlemen are experts in this field. It's a safe place. So let's ask any types of questions.
Well, thank you, MR. Thank you for the opportunity. We're glad to be here. Just a quick intro of who I am and who we are. I'm Joe Calhoun, Associate Director of Business Development here at PERC. And part of my responsibility at PERC includes propane power generation, product lines, and business development activities at PERC. With me today, I have Gokul Vishwanathan, my colleague. He is our Director of Research and Sustainability. So thank you. Just quick introductions about the series and what this series is. We're going to do a whole series of presentations along with our partners. When I say our partners, so PERC works with a number of OEMs to provide technologies for propane use. When it comes to CHP, we're working with a number of manufacturers in the space throughout its product range. And we're going to have each of them speak to you on different days coming up. Today is going to be an introductory session, and we're also going to talk about these industry partners that we have. So here's what the series looks like. We've got this opening session coming up. We've got Blue Mountain and Eisen. Blue Mountain is a technology for cooling in addition to heat and hot water. And Eisen is a hot water and heat combination. So they're tag teaming together. Blue Mountain doesn't have the power component to their technology. Brash is a combined heat and power unit, and Axiom also combined heat and power, as well as EnviroPower and Lochinvar. And then Gokul and I will be finishing this session on the 17th of June with kind of just a wrap up of all that we've learned throughout this series. So no need to worry about Zoom links. If you've got one Zoom link for this presentation, you've got them all. It's a reoccurring series that MR has set up from Virtual Propane Expo. So what is CHP, or combined heat and power? We're going to talk a little bit about that, how it works. We're going to talk about our industry partners and also where the opportunities are for the propane business. We're going to have a deeper dive into how it works, talk about efficiency, black start, talk about where CHP works and the concept of spark spread, as well as training resources that we have available at PERC, and maybe even talk a little bit about energy as a service and why, as a model, it's an important one to understand first and foremost, but maybe even move towards as a model for doing business in the propane industry with products like CHP. And most importantly, I think if we start with why CHP, and we'll get there in just a minute, but let me start with giving you kind of a picture of the opportunity for CHP and what it is. So what you see in this infographic in the middle, in the basement, perhaps, and most likely in a basement or utility room, it's going to be a micro CHP unit. It's going to be, in some cases, the footprint of your furnace, maybe smaller, maybe larger, depending on the unit. And it will be supplied with water. It'll be supplied with a fuel source, propane, and its outputs are hot water, heat, and electricity. Now, but wait, there's more. On the electricity is the power that you generate in a micro CHP unit can also be put back out onto the grid. So what we're talking about here is not just resiliency from the standpoint of unplugging your home from the grid, but having the ability to provide grid back to, or excuse me, power back to the grid. So what does that look like from how each individual unit works? Well, you're going to have some kind of prime mover or combustion turbine, maybe a reciprocating engine in your larger CHP applications. Where does it go? It's going to go throughout that building space, and it'll drive a generator or a turbine, and it'll also go through some kind of heat recovery unit. It might just be a simple heat exchanger that generates electricity, that generates heating and cooling, generates hot water for your home or for your business. And it also produces all of this at a very high efficiency. So when it comes to CHP and micro CHP, there's really a line of departure between what is micro CHP and what is considered CHP. In the micro side, it's everything from, say, 1 kilowatt to 50 kilowatts, and CHP is anything 50 kilowatts and above. So what does that mean? So for the average single family home, 18 to 25,000 square feet, 100 square feet really, not 1,000. We're talking about a 1 to 3, maybe 5 kilowatt power unit. In a larger single family home, maybe with a greater load, maybe you've got an outdoor pool that you need heat for. Maybe you've got an AC system, you would need a greater draw or greater load. So you're going to be in that 3 to 10 kW range. Could be a multifamily unit, or it could be a light commercial use, maybe something like a car wash. In that 10 to 50 kW range, you're going to have much larger multifamily dwellings like an apartment complex or a commercial industrial establishment, a business park, a restaurant. And then on the large scale CHP opportunities, these are for large commercial, industrial applications, warehousing, manufacturing, distribution, utility power, essentially for those kinds of large scale. So I did say why, the why of the what, and I often say we need to start with why. And why CHP and why now and why propane? These are all great questions that we get asked all the time. Counted a little bit historically, in mid-February in Texas, grid failures amounted to 4.5 million customers being without power. In some areas, propane was the only thing providing power solutions in those areas that were hit for days on end without power. Propane as a resource is reliable, resilient, provides these power solutions, whether it's behind the grid or behind the meter rather, or off grid or not. Another good why of the what, and something that's come out recently, is FERC has established 2222. This FERC 2222 ruling means that net metering is easier than ever to do. So net metering is the arrangement that I talked about a little bit earlier, where you can have a unit and have it be in your home and sell grid power back or power back to the grid. What does that mean? Well, that means you're going to have an arrangement with whoever the utility partner is. And that net metering arrangement, because of FERC 2222, the tariffs and the field, it's been a more level playing field for propane marketers to participate in this kind of utility or near utility, because you're really kind of being a self-sufficient, being your own utility. So let's take a look then at the partners that we're engaging with just for this series. And you can see how they align with power needs. All of these folks will be speaking in the coming weeks. And like I said, we've got some nice alignment with power ranges for CHP application. In the 1 to 3 kilowatt range, the icing unit, and again, it pairs well with the Blue Mountain Energy rooftop unit. Often those units are daisy chained together for larger applications, but on their own, they're a smaller application. In the 3 to 10 kilowatt range, we've got Axiom Power, Brash, and Viro Power. And you can see those units there, the two on the right below the text, Brash and Enviro Power respectively. And like I said, they're about the size of a refrigerator. So not much bigger than your existing furnace today. The Echo Power unit from Axiom is about half that size. In the power range of 10 to 50 kW, Lochinvar has units that are in that range as well, and a little bit different because they don't have black start capabilities, but we'll talk about black start later. And in the large CHP power ranges and capacities, typically Capstone for propane power, anything in that 1 meg range is a Capstone kind of application. Capstone does have some smaller units in the 10 to 50 kilowatt range, I think around 35 and maybe 45, something like that. But again, they're often daisy chained together for multiple applications. So when we look at our industry partners that we're aligned with, we are also aligned with ways to engage with our industry and this technology. So at this year's Southeastern Trade Show, World Expo, which will be in Atlanta this year, we're going to have inclusion of some of our product partners in the New Products Pavilion. We are also engaged with an organization called CHP Alliance to promote CHP, micro CHP applications. We're also engaged with DOE's CHP Technical Assistant Partnerships, or TAPS. This is a group. You can see this map. That's the CHP TAPS. They go by an area, if you will, and we're able to get you those contacts. If you're in an area where you'd like to hear more about who is your TAP, we can connect you with those local resources. But the TAP program is there to establish case studies and really give you a catalog of opportunities to choose from in a given fuel space and given the right requirements. So I'm going to have Gokul dig in a little bit deeper into how CHP works, and then I'm going to finish up from there. So I'm going to mute myself.
Thank you, Joe. I believe you will be, forwarding the slides for me. So I'll just say next slide when it comes. So thank you again. I am Gokul Vishwanathan, the Director of Research and Sustainability, as Joe introduced me before. So just to take a little bit deeper dive on combined heat and power and why we want to focus on combined heat and power. I mean, typically combined heat and power is also called as cogeneration. Predominantly, that's a term used in Europe than the US. And it offers tremendous benefits, energy efficiency, and also emissions benefits as compared to centralized power generation. So the chart, top right chart that you see kind of roughly mimics what a centralized power plant would do, is that you provide 100% of your fuel energy. Much of it is wasted in a central power plant with the stacks, right? About 60 to 65% of it is wasted. Then you have transmission and distribution losses of electricity from the power station to the end customer, which is a residential or a commercial facility in this case. And so the net efficiency of power generation is somewhere around 33 to 35 in the US, approximately. That is from a US average standpoint. I mean, of course, it also depends from state to state. While CHP, on the other hand, it refers to local power generation, or it is closer to the demand, as Joe pointed out before. It is on-site power generation. So point number one, you don't have any transmission and distribution losses because of CHP. And also it provides that additional resiliency that Joe was talking about, in terms of some of these units can operate independent of the grid and provides you additional resiliency. On top of that, the waste heat from a CHP unit can be tapped in for providing hot water and space heating needs, which is kind of the antithesis of what you see in a power plant, where the rejected heat is rejected out into the environment through cooling towers. And so hence the CHP has a net efficiency which is much higher than a central power plant efficiency. So typical CHP units can go over 90% efficiency or even higher from a fuel heating, lower heating value standpoint. Pretty much about 30-35%, let's say, from an electricity generation, and the 50 to 60% from a heat capture standpoint. To show this, if you look at the bottom right chart, if you look at the bottom right chart towards the right hand side, a CHP unit takes in 100 units of fuel, let's say, of which 30 units are converted into electricity. So about 70 units of the fuel are wasted out as waste heat and friction and all that, let's say, of which if you're able to even capture about 45 units for steam or hot water or for space heating, your net efficiency is about 75%. So that is much higher than centralized power generation, and also having a boiler or a separate hot water heater and a furnace, which on the left shows it's about total efficiency of about only 50%. So in addition to just energy efficiency, lower carbon dioxide emissions from an environmental standpoint, and also resiliency, these are the three key attributes that a combined heat and power system can offer to any end customer, and also for utility. So there are typically two types of CHP systems, broadly speaking. One would be an electrically led system, and one would be a thermally led system. Typical CHP systems, conventional CHP systems, are thermally led systems. What I mean by that is the CHP system can either follow your heating load of a residence or a commercial facility, or they can follow your electrical load of your residence or commercial facility, right? They can either satisfy your heating demand completely, or they can either satisfy your electricity demand completely, right? So if they follow the electrical load, the heat is just a byproduct and you get what you get. And if that's the case, then you might need an auxiliary hot water or space heater to satisfy your peak heat load demands. Now, if you are sizing your CHP system to the peak heating load of the residence, then it's going to satisfy all your heating demand, be it your hot water or space heating. It's going to satisfy all of that. However, the electricity that is produced is a byproduct, right? You produce what you produce when you produce, depending on when the CHP system is on to satisfy the heating needs, right? So in that case, there's no auxiliary or hot water or space heating needed, but the electricity that is produced is just a byproduct. You don't have a control of how much electricity is produced. Specifically, heating is needed, let's say, for 6 to 8 months predominantly, 6 to 7 months predominantly, and then you have a little bit of hot water demand. Maximum generation of electricity would only be restricted to those 6 to 7 months of the year, right? And then where does it make sense? And we'll come back to this term called as spark spread, and I have some charts to show on that. For the time being, just assume that a favorable spark spread is good for any kind of a CHP system. Essentially, spark spread is just a measure of what is the dollar value of producing that electricity versus what is the dollar value of if you're purchasing that electricity. What is the difference between them is essentially the spark spread. And if you're able to produce on-site electricity cheaper as compared to what you're purchasing from the electricity grid, you have a favorable spark spread, right? And so higher the spark spread for the CHP system, better it is for the end user or the consumer in terms of the device payback. In terms of an electrically led system, it can operate at a constant load, satisfy your base load of the home, and it does not need much start stops because you need electricity around the clock. In terms of a thermally led system, like I said, you might have, just like your furnace, turns on, turns off, so on and so forth. So you might need a lot more start-stop kind of an operation. So the attributes of the system that you're designing has to be careful for a thermally led system as compared to an electrically led system, because a thermally led system is going to have a lot more fatigue, let's say, because it's going to turn on and turn off and so on and so forth, as compared to an electrically led system. So micro CHP, where does it work? I just mentioned that we'll talk about spark spread. So this is a chart that I had prepared during my days as a consultant at the Department of Energy. This has nothing to do with propane, but this has to do with natural gas. But a similar kind of a chart can be prepared for propane, which I will show in the next few slides. What we did here is essentially look at a state-by-state analysis of where does it make sense to have CHP units. And typically, if you see this, that CHP units are more favorable towards the northeast of the US, where you have a very high spark spread, and the Midwest, like Wisconsin, Michigan, Minnesota, Montana, Colorado also, and also California, where some parts of California necessarily do not have a very high heating demand, but the price of electricity is very expensive in California. So you get a favorable spark spread if you're able to generate locally electricity using natural gas or propane, for that matter. But if you look, there is a vacuum in the southern states, right from Arizona to all the way to Florida, because there's not much heating demand in these states, right? I mean, you don't need much heat in these states. So the spark spread doesn't make sense in these states. Hence, you don't get a favorable payback. So the chart on the top actually shows the spark spread, and the chart at the bottom shows the payback, right? So higher the spark spread, let's say 70, take a number 70 here, right? Lower is the payback period, right? So it's the other way. So higher the spark spread, lower is the payback period. A customer wants a lower payback period, right? So for example, take an example of Alaska. It has a very high spark spread and a very low payback period, right? So these two go hand in hand. They are correlated with each other. So spark spread is very important when you're considering installation of a CHP unit, let's say. And like I said, it makes a lot of sense in Northeast, where there's tremendous amount of spark spread and heating demand. Makes sense in Midwest, again, tremendous amount of spark spread and heating demand, and California, of course, Alaska, and few other states peppered in between. So we did a similar kind of an analysis, not from a state by state basis, but from a region by region basis for propane. And these are some of the kind of assumptions in the model. I don't want to dwell down into the nitty-gritty details of this model. But what I would rather want to focus on is essentially look at some of the results that we got out of this simple techno-economic payback kind of a model. So we did this, we exercised this model for a typical residential facility and also for a light commercial facility. And in this case, we only consider the cost. The value is not quantified. For example, lost revenue or lost value of products and goods during power cuts is not considered here. It is just the cost of the system and the payback of the system is considered. But if you think about it, resiliency, there is a value for resiliency, right? I mean, consider Texas, like Joe pointed out, right? Several million customers were without power. Several million facilities were without power. There is lost revenue, there is lost goods, and loss of comfort as well from a personal standpoint. So that value has not been quantified, and it seems that the value is getting even more important by the day as we are seeing more and more power cuts around the country. So we did the same kind of an analysis for propane. So if you look at this chart, there are two numbers that are given, essentially the dollar per kilowatt value of a typical CHP system, residential CHP system, micro CHP system. We consider a payback of 10 years, which is pretty large. Typical customers would want a payback less than 5 years, but we consider 10 years because an average homeowner today owns a home for roughly 12 years. This is the recent data. So we consider a payback of 10 years. If you consider this payback of 10 years, if you look at New England area, the device, if it's a 1 kilowatt unit, the device has to be developed the device has to be total installed price of the device has to be close to $4,000. If it's a 2 kilowatt unit, it would be close to $8,000. It's just a dollar per kilowatt value, right? And if you go to, let's say, the southern portion of the US, the other end of the US, where it has to be extremely cheap, such as $400 a kilowatt, which is not possible, right? Because there is no heating value, like I said before, for the southern portion of the US, or there's not enough spark spread. So the southern states are kind of eliminated. Natural process of elimination takes place for the southern regions of the US because it's impossible to make a device for about $300 or $400 per kilowatt. So you just have to focus on the Northeast, the Californias, somewhere in the mountain areas and the north central areas of the Midwest areas, essentially, right? So in terms of gallon growth potential, Northeast provides you an approximate gallon growth potential of 74 million gallons. This is because for this particular price point, if you look at the previous slide, actually, for this price point, we assume what would be the market penetration. And based on that market penetration, we calculated what would be the gallons potential of sales for propane. So the Northeast gives you a gallons potential of about 75 million gallons. Atlantic gives you about 80 million gallons. While California, by the state by itself, gives you a potential of about 20 to 25 million gallons on a yearly basis if you're doing residential CHP. So from a price point, a 5 kilowatt unit, let's say, for light commercial or residential facility should cost anywhere from $7,000. Basically, for the mountain area, that's the lower end of the spectrum, and the higher end of the spectrum is New England, which is about, like I said, $4,000 a kilowatt, close to $20,000 for a 5 kilowatt unit. So that's kind of the price point where we see that a market potential can be obtained and the significant market penetration can be obtained. We did a similar kind of an analysis for light commercial facilities. So in a light commercial facility, again, the southern states are eliminated, but of course you have similar kind of a trend for the Northeast Atlantic, the North Central regions, Mountain and California. So yeah, so if you look at this light commercial, so New England again gives you a potential of about $3,000 a kilowatt. California gives you a potential again about $3,000 a kilowatt, and the Atlantic and the Midwestern states are somewhere in between those values. The challenge here is at a light commercial scale, you're selling like a 20 to 25 kilowatt unit. So at $3,000 a kilowatt, your product price or the total installed price has to be somewhere close to $70,000 to $75,000, right? And which is possible for a 25 kilowatt system. There is tremendous amount of potential for light commercial. In addition, light commercial has a slightly different twist as compared to residential, where facilities such as restaurants might need year-round heating and hot water will be needed. And so there is also value for light commercial entities such as restaurants, even in southern states, where there is value for heat all around the year and there is value for electricity all around the year. So the product attributes become a little different for light commercial facilities as compared to residential facilities. So we see that there is definitely potential for residential, but the light commercial is where you can develop the economies of scale between, let's say 10 kilowatt to let's say 30 kilowatts. You can develop the economies of scale, and then you can go into the residential sector and have further reduce your price for the residential micro CHP unit. In terms of market opportunities, let's dig into a couple of this just shows how important the total installed price of a unit should be. So this chart on the right shows three different prime movers. One is a Stirling engine, which is a 1 kilowatt Stirling engine. One is an internal combustion engine, which is a 1 kilowatt internal combustion engine, and one is a fuel cell, which is the 1 kilowatt fuel cell. If you look at the blue bar, that kind of gives you what the system cost is, and the purple bar on top of that is the MSP margin on top of that. And so when you talk about the fully installed cost with no tax, that's the green bar right on top of that. And when you consider the fully installed cost and tax, that's the yellow bar. That's the top of it. That's the 100% cost, right? So if you look at the product price, which is the blue bar of the system cost, that could be anywhere from 20% to let's say 40%, right? The rest of it is all soft costs, in my opinion, including the margin, the installation cost, taxes, and so on and so forth. So whenever we do a payback analysis on micro CHP units, it is important to consider total installed cost as compared to just the system cost. System cost is just one small component into the entire equation. So in terms of business models, this actually begs that we need to create, or we need to look for new business models for improving market penetration. So if you look at the top right chart, that is the typical heating, ventilation, and air conditioning, or HVAC business model chart. For example, if you have to target a price of $3,000 on the top right, you have to develop a product for $660. The reason being that the cost of goods sold is $660. Then it is sold to an OEM. There is a markup for that, 30% markup on it. And the OEM integrates the package, and then there is an additional markup on that. Then it is given to the distributor. There is an additional markup for that. It's given to the dealer. There is an additional markup on that. And then ultimately the dealer puts it to the customer, right? So if you go through this traditional channel, as you see, if you have to sell something for $3,000, you have to make something for $600. And that's extremely challenging, right? But there are other kind of channels that you can exploit here, is that you directly bypass the OEM and the distributor, you directly go to the dealer, where you make the entire system, integrate the entire package, and directly go to the dealer, and dealer sends it to the customer, or you directly go to the distributor and then the dealer and the consumer. So as you see, we need new business models so that the end price to the customer has to be lower, so that we can get several of these micro CHP units installed. The typical HVAC distribution channel is probably not going to work unless you are able to manufacture it at an extremely low cost, which is pretty challenging, because customers would expect these to survive for 15 years, similar to a typical HVAC unit, a furnace that can go up to 10 to 15 years in your home. So that's the challenge for us, and an opportunity to exploit for us for micro CHP units. In terms of certification requirements, I want to go breeze through these slides. Certification requirements for micro CHP from an emission certification standpoint, except California, you have to go through the EPA certification norms. The hydrocarbon NOx and CO standards are given here. I wouldn't dwell much into it. Specifically for California, there is a 2007 distributed generation certification requirement. And as you can see, the NOx, CO, and the volatile organic compounds, the text in red that is given here, those are extremely challenging for any kind of combustion system to meet, be it an internal combustion engine, turbine, or Stirling engine, or anything like that. fuel cells are typically able to meet these. We are getting news that newer internal combustion engines are able to do that. So apart from meeting these targets, California also requires you to do a test for over three to 4 months to make sure that your emissions do not degrade over time. So there is an additional qualifier along with this emissions regulation. So as you can see, California is a tough market to penetrate, but it's also an opportunity to penetrate market from a market penetration standpoint, because there are tremendous number of incentives offered for micro CHP units. And then on top of that, you need the UL 2200 safety for stationary engine generator certification. You also need an UL 1741 certification or IEEE 1547 for interconnection requirements. These are particularly important if you're especially going to put back, if it is grid tied A, and B, if you're going to put power back into the grid, like UL 1740, 41 or IEEE 1547 is extremely important to be certified. So you see all these different certification requirements that also add to the soft cost when you're considering selling these units. So finally, this is my final slide. So in terms of micro CHP product installation or integration with other technologies, specifically for propane, when you're considering black starting, what do I mean by black starting is if you're grid tied and the grid goes down, you want a mechanism to start the unit so that you have a base electricity load in your home, even if the grid goes down, aka Texas, or you need heating and hot water on top of that, along with electricity, right? So for that, some kind of a battery integration is very important. That can kind of kickstart the unit when the grid goes down. And battery is also important for fuel cells, which are not typically good for following loads, and Stirling engines, which are not typically good for following the loads. If you're especially following the electrical load, batteries could be good for that. And then some amount of solar PV and battery backup integration would also be good. Although solar PV and battery backup, solar PV solution, that system solution could also be considered as a competitor to this, to these units. At the end of the day, it's the customer, the price to the customer is what's going to define whether a particular attribute of the system is going to be marketable, right? Because if you have a solar PV, a battery backup, and a CHP system, the cost is going to be egregious at the end of the day for a residential customer. It might make sense for a commercial customer, but it might not make much sense for a residential customer. And also from an electrification standpoint, a micro CHP with a propane unit that is producing electricity, it could also open avenues for integrating electric heat pumps. In this case, the propane is used to produce the electricity using a generator, and that electricity is used to power an electric heat pump. So there are other synergies that could be exploited using micro CHP. So thank you again for the opportunity. I believe that's my last slide, Joe. And over to you. I'm happy to take any questions at the end of this presentation.
There are some questions that have come in through the chat. I think I'm frozen. Do we want to pause a second and look at those questions first, or let's just go through the last few here? It's really just some conclusions and a call to action. Let's talk a little bit about all of what we've just talked about. Might look like this word salad. It's a lot of information. There's a lot of opportunities. This is some of where you will find them. And PERC is really aligned well to be your partner in this process and kind of help you sort through the jumble, what is CHP and the applications. But the sales of this technology, as Gokul was saying, it's not an easy sell. It's going to take alignment with partners. It's going to take alignment with a solar power storage partner, plumbers, electricians, HVAC technicians. The joke I like to tell is plumber, the electrician, and a propane guy go into the bar and they come out and they sold him a CHP unit, because it takes that kind of collaborative approach, right? The residential micro CHP market is turning the corner on the wake of COVID. More people are wanting to be on their own. They want to be off grid. They want to cut the cord. They want to be able to be their own utility for a lot of the reasons we're seeing, like the Texas grid failure. And beyond just being a backup source of power, this is total resilience. So if you want to learn more, where can you go for some training? I would suggest that if you want to get engaged with CHP, go and check out our 5 training modules in the Learning Center at propane.com, you'll find 5 different training modules there that are an introduction to strategic partnerships. Now, they're not all about CHP space per se, but of how the propane marketer can align with a number of partners in a number of categories. But it works very, very well in this space. And if you want even more continued education and to learn more about CHP, we've actually partnered with a company used to be known as Hanley Wood or Zonda, and they have a continued education course online. We can get you those links as well, where the learning objectives are just like you see here, to explore micro-combined heat and power on a more in-depth level. You'll see some on-site applications. You'll see some case studies. You'll see where it works in terms of, and some calculators used to determine where it works well. And you'll see some examples today, as well as being able to analyze the benefits and the advantages, etc. Questions? I can go to the queue and see if we've got any other live ones. I'm not sure how you want to do that, Mary Rachel, but we've got several maybe in the chat. So we just have a hello, Shane. You've got a fan out there. Also have one that says check out DOE's package CHP catalog. Yeah, so that CHP catalog is what we'd referenced in the presentation today. The CHP TAPs are the ones that are responsible for maintaining that catalog. The TAPs are these technical partners to anyone and everyone that wants to be engaged with CHP. And we can connect you to the right partner in your area. And then there's another reference here to the PERC calculator. That's right, there's a PERC calculator for CHP. For even more, go to propane.com CHP. It's right there for everybody to see and write down. I'm Joe Calhoun, Associate Director of Business Development, and it's just joseph.calhoun at propane.com. And Gokul Vishwanathan, he's our Director of Research and Sustainability, and gokul.vishwanathan at propane.com. And I think the other thing to highlight is if you've got questions about any of the units that you saw or the ranges, save those for later too. You're probably wondering, well, how many gallons is this and what's the opportunity? They may vary from unit to unit, but we're going to have the opportunity to listen to each of these partners talk about their specific product and talk about specific applications and its use with propane. So I'm really looking forward to digging in each week and asking each of our partners more questions and seeing how all of this benefits our industry. MR, thank you so much for the opportunity. Shane, thank you. I would be remiss if I didn't thank Shane. I initially approached Shane and said, "Hey, Shane, I've got an idea to present a couple of our partners. Are you guys interested?" He says, "Let's make it a whole series." And I really love the idea of making it a series. So the other thing to think about too, if you're listening in and seeing this, is for if you've got a crazy idea that maybe you want to try one of these, we are looking too for test bench opportunities to use a unit, to have it installed, to be able to be part of research.
Thank you for the opportunity again, and I'm sorry my throat is a little hoarse. I had to cough a little bit, but thank you again for the opportunity to talk to the group.